Something just happened inside Tesla that has the entire auto industry on edge. While every company was racing for bigger batteries, longer range and flashier designs, Elon Musk quietly focused on something no one was paying attention to: the motor. That small, silent machine buried deep under the car, the one that doesn't get headlines or hype, has just changed everything. Tesla has unveiled a motor so efficient, so durable, and so affordable that it might rewrite the rules of the EV game. And here's the twist: it does all this without depending on rare earth magnets, the same materials that most carmakers still rely on. This move isn't just a technical upgrade, it's a direct message to the entire industry. Because if Tesla can make electric cars faster, cleaner, and cheaper without using materials the rest of the world is fighting over, then everyone else has a serious problem. So what exactly has Elon Musk created this time? How did a simple motor suddenly become the biggest threat to legacy automakers, and possibly the start of an entirely new era for electric vehicles? Let's break down how this quiet revolution began, and why every engineer on the planet is now watching Tesla's next move. When people talk about electric cars, the conversation almost always circles around the same things: range, charging time, and design. The battery gets all the glory, the software gets the hype, and the sleek body grabs the attention. But under all that noise, there's a hero that almost no one talks about: the motor. It doesn't glow, it doesn't make a sound, and it doesn't demand attention. Yet, it's the very reason an electric car moves at all. It's the beating heart that converts invisible electricity into unstoppable motion. And Tesla just changed how that heart works. This new motor isn't just another mechanical upgrade. It's a breakthrough that flips the idea of power on its head. Instead of focusing on raw strength, Tesla engineered a motor that's smarter, lighter, and dramatically more efficient. One that can deliver higher performance while costing less to build. The best part? It achieves all of this without leaning on rare earth magnets, those same expensive and environmentally damaging materials that most of the world's automakers are still dependent on. For years, companies have thrown billions into batteries and aerodynamics, hoping to squeeze a few extra miles of range. But Musk decided to look where no one else was looking: inside the motor itself. Because in his view, the real future of electric mobility doesn't lie in how far you can go, but in how intelligently you move. And that's exactly what this new Tesla motor represents: the shift from brute power to smart power. But to really understand how massive this change is, we have to rewind a little, back to a time when electric cars were a joke, and one strange inventor's dream was about to be reborn more than a century later. Before Elon Musk ever dreamed of revolutionizing transportation, there was another Tesla, the man who gave electricity its soul. Nikola Tesla wasn't just an inventor, he was a visionary centuries ahead of his time. While others chased fame and fortune, he chased ideas that seemed impossible. Back in the late 1800s, when most of the world still relied on steam and gas, Tesla was already experimenting with wireless power, electric motors, and energy transmission that didn't need a single drop of oil. He imagined a world where motion came from pure current, silent, clean, and endless. Sound familiar? That's the foundation Elon Musk built his empire on more than 100 years later. The name Tesla wasn't just branding, it was a tribute to the man who dreamed of powering the planet with nothing but electricity. But here's the twist most people don't know: Nikola Tesla actually designed one of the earliest versions of the induction motor, the same fundamental concept still driving every Tesla car today. It was small, efficient, and decades ahead of its time. Yet, like most of his work, it was forgotten, buried under corporate politics and financial ruin. When Elon Musk's team chose the name Tesla Motors, it wasn't just about paying homage. It was a quiet declaration that they were picking up where Nikola Tesla left off, bringing back an idea that the world wasn't ready for. And with this new generation of electric motors, that legacy is more alive than ever. Because while Nikola Tesla's dream was lost to history, Musk's version is making sure it powers the future. But how exactly did Tesla's modern engineers turn a 19th century invention into the most advanced motor on the planet? The answer starts deep inside the technology that changed everything: the permanent magnet revolution. For decades, automakers believed that power came from one thing: permanent magnets. These small but incredibly strong components turned electric motors into high-performance machines, capable of pushing cars to insane speeds with whisper-silent precision. The secret behind them was something called rare earth materials, elements like neodymium and dysprosium that could generate immense magnetic fields. These materials made electric cars faster, smoother, and more reliable. Companies like Toyota, General Motors, and even early Tesla models used them to dominate the EV space. But there was a dark side to this revolution. The mining of rare earth metals is one of the most toxic and environmentally destructive processes on the planet. Mountains get stripped, rivers turn toxic, and entire regions become wastelands just to extract a few tons of material. And here's the kicker: nearly 90% of the global supply comes from China. That meant one country held the keys to nearly every electric car motor in the world. And for Elon Musk, that was a ticking time bomb. While other automakers quietly ignored the issue, Tesla engineers started looking for a way out, a design that could deliver the same torque, acceleration, and range without relying on rare earths at all. It sounded impossible. Experts called it risky. Investors said it was a waste of time. But if there's one thing Musk is known for, it's doing the exact opposite of what the industry expects. And in 2023, during Tesla's Investor Day, he finally revealed the answer: a next-generation motor with no rare earth magnets, zero dependency on fragile supply chains, and better performance than ever before. The announcement didn't just shock the industry, it shook it. Because if Tesla could really make this work, it wouldn't just change how electric cars are built. It would rewrite the global power balance of the EV world. But how did Tesla manage to do it? What technology made this magnet-free motor even possible? The truth lies in a radical redesign of how energy flows inside the motor, a concept known as inductive drive technology. So how do you build a powerful electric motor without the very thing that makes it powerful, magnets? Tesla's answer was to completely rethink how the motor generates motion. Instead of relying on rare earth magnets to create a fixed magnetic field, their engineers turned back to an older, almost forgotten idea: induction. In a traditional induction motor, electricity isn't just used to spin the rotor, it's used to create the magnetic field itself. Think of it like electricity controlling electricity. The result is a design that's smoother, cleaner, and far easier to produce at scale. But Tesla didn't just bring the old design back, they supercharged it. Their new motor uses advanced power electronics, carbon-sleeved rotors, and next-gen silicon carbide inverters to push efficiency to levels that were once thought impossible. Every component was redesigned to reduce drag, improve cooling, and minimize energy loss. In simpler terms, the motor learned to think. It adapts its power output in real time, responding to road conditions, acceleration demands, and even driver behavior. The software talks directly to the hardware, a closed feedback loop that gives Tesla vehicles that trademark instant torque and ultra-smooth drive. And by removing rare earth magnets altogether, Tesla didn't just solve a supply chain problem. They cut costs, reduced environmental impact, and built something the competition can't easily copy. That's why, when Musk revealed this design, it wasn't just an engineering upgrade. It was a statement that true innovation isn't about adding more, it's about removing what doesn't belong. But while Tesla was busy refining the future, the rest of the world was watching nervously. Because for some of the biggest automakers, especially in China, this new motor posed a serious threat. And what happened next turned into a quiet war that most people never even noticed. When Tesla revealed its magnet-free motor, it wasn't just a technical victory, it was a direct challenge to China's dominance. For years, China had quietly built an empire around rare earth mining, controlling nearly every stage of production. From the mines in Inner Mongolia to the factories refining neodymium, Beijing had one of the most powerful economic levers in the world, and the entire EV industry depended on it. Then suddenly, Elon Musk's announcement threatened to pull that power away. If Tesla's new design worked, it could make China's rare earth monopoly nearly worthless overnight. Billions in investments, countless mining operations, and even national strategies were at stake. That's when the quiet war began. Behind the scenes, Chinese automakers like BYD, NIO, and Geely scrambled to respond. BYD, already a dominant player, doubled down on its own technology, investing heavily in synchronous motors and experimenting with hybrid magnet systems that could rival Tesla's performance while keeping costs lower. At the same time, China tightened export controls on key rare earth materials, limiting how much could leave the country. Officially, it was about resource management. But insiders knew it was a warning, a message to the West: don't think you can escape us that easily. Still, Tesla wasn't backing down. In fact, Musk seemed almost energized by the challenge. He even hinted that the company's next-generation vehicle, the rumored $25,000 Tesla, would use this new motor as its backbone. A global, affordable EV that doesn't depend on rare earths at all. If that happens, it won't just reshape the car market, it'll redraw the global energy map. Because once a single company proves it's possible to build world-class EVs without Chinese materials, everyone else will follow. But this isn't just a story about global economics or technology. It's also about timing, and Tesla has a history of being ahead by just enough to change everything. And what they're planning next might be the boldest move yet, a design so efficient, it could make current EVs look outdated overnight. By the time most automakers catch up to Tesla's last innovation, Musk is already working on the next one. The company's secret isn't just its technology, it's its speed of evolution. And nowhere is that clearer than in Tesla's upcoming ultra-efficient platform. Internally known as the third-generation vehicle architecture, this platform is designed around one core idea: do more with less. Every component, from the chassis to the motor, is being redesigned to maximize efficiency, minimize cost, and eliminate waste. At the heart of it sits the new magnet-free drive unit, smaller, lighter, and cheaper to produce. Musk claims it will deliver the same performance as today's Model 3, but with half the production footprint and zero reliance on rare earths. To make that possible, Tesla is using a combination of modular casting, gigapress technology, and integrated thermal systems, a production philosophy that turns what used to be 300 parts into just one. The result? Cars that roll off the factory floor faster, cleaner, and cheaper than anything else on the market. And the most shocking part, this next-generation car could be priced at just $25,000. That's not just a number. That's the price point that breaks the EV market wide open. A car like that, with Tesla performance and global availability, could outpace every major competitor overnight, including legacy automakers that still rely on decades-old production models. If successful, this platform won't just redefine Tesla's future, it'll redefine what the entire industry looks like. Because once Tesla proves that innovation can be both cheaper and cleaner, every company on the planet will have to follow or fall behind. But here's the catch: every revolution comes with risk. And Tesla's push for efficiency might also push the company into new territory that even Musk can't fully control. What happens when Tesla's biggest threat isn't another company, but itself? Every great innovation carries a hidden cost, and for Tesla, that cost might be its own momentum. As the company races forward, breaking records and rewriting engineering rules, it faces a new kind of danger, one that doesn't come from China, legacy automakers, or even regulation. It comes from within. Tesla's culture has always been built on chaos, pushing teams to the limit, forcing impossible deadlines, and demanding results that other companies wouldn't even attempt. It's part of what makes the brand unstoppable. But it's also what burns people out, leads to production delays, and sometimes, costly mistakes. The faster Tesla evolves, the harder it becomes to maintain consistency across its growing empire, from Fremont to Berlin to Shanghai. Each gigafactory is a beating heart of innovation, but also a pressure cooker. And then there's the question of Musk himself. He's not just the CEO, he's the face, the voice, and the story. Every tweet moves markets. Every offhand comment becomes a headline. His relentless drive fuels Tesla's success, but it also fuels controversy. For investors, that's both thrilling and terrifying. Because here's the reality: Tesla isn't just building cars anymore. It's building a vision of the future, one that merges AI, robotics, and energy into a single ecosystem. That's a level of ambition that no automaker has ever attempted. And when you aim that high, one misstep can shake the entire structure. Still, that's what makes Tesla different. Where others see risk, Musk sees opportunity. Where others see failure, he sees a prototype. And that mindset, the same one that nearly destroyed Tesla in its early years, might be exactly what keeps it ahead now. But while Tesla fights its internal battles, the rest of the world isn't standing still. Because somewhere else, in labs across the globe, a new kind of electric revolution is taking shape, one that could challenge everything Tesla has built. Tesla may be leading the charge today, but the race for electric supremacy is far from over. Across the globe, automakers are scrambling to catch up, and some are innovating in ways that could challenge even Musk's empire. In China, companies like BYD and NIO are not just building cars, they're creating entire ecosystems. From battery technology to autonomous fleets, they are quietly matching Tesla's pace. Europe, meanwhile, is investing billions into solid-state batteries and next-generation motor designs that promise longer range and faster charging than anything on the road today. And then there's the United States. Legacy automakers like GM and Ford are finally waking up, pouring resources into EV platforms that combine performance, affordability, and scale. But for all their money, many are still years behind Tesla's integrated approach, the blend of hardware, software, and intelligent design that Musk perfected. The battlefield isn't just technology, it's supply chains, rare earth alternatives, and global manufacturing. Tesla's move toward ferrite magnets wasn't just about efficiency, it was about survival. A future where millions of electric cars can't depend on a single material or country isn't just smart, it's essential. And the stakes go even higher. Musk isn't simply building cars, he's building a network of autonomous, connected vehicles that could redefine transportation entirely. Imagine millions of self-driving Teslas, talking to each other, sharing data, and learning in real time. That's not science fiction, it's the world Tesla is quietly building, piece by piece. If Musk succeeds, the entire EV landscape could shift overnight. But if he fails, the industry will rush in to fill the void. The race for the future is no longer just about speed or range. It's about intelligence, sustainability, and control. And Tesla has just taken the first step toward defining who will dominate that future. Yet, the quietest revolution is often the most powerful, because sometimes, the changes that truly move the world forward don't roar.
They whisper.
Imagine if every time you slowed down, your car could actually charge itself. That's exactly what Tesla's regenerative braking does, turning ordinary motion into electricity. Traditional cars waste energy every time you hit the brakes. The brake pads generate heat, the energy disappears, and your fuel is gone. Tesla, however, flipped the concept entirely. When the driver presses the brake pedal, the motor doesn't just stop the wheels, it starts working in reverse, converting kinetic energy back into electricity and storing it in the battery. The effect is subtle but revolutionary. Drivers may barely notice the car slowing differently, but that tiny difference adds miles, efficiency, and sustainability to every journey. On long trips, regenerative braking can contribute significantly to overall range, turning city driving, with constant stops and starts, into a miniature charging cycle. It also reduces wear and tear. Brakes last longer, maintenance costs drop, and the energy that was once wasted is now put to work powering the car. What's even more fascinating is how this system ties directly to Tesla's new motor design. The smarter the motor, the better it can manage regeneration, distributing energy, balancing torque, and keeping the ride smooth while quietly reclaiming power that would otherwise be lost.
And the best part?
This isn't just an eco-friendly feature. It's a glimpse into a future where cars are no longer passive machines, they're intelligent partners in motion, constantly optimizing themselves to drive further, cleaner, and smarter. But regenerative braking is just the beginning. The next breakthrough lies deeper in the motor itself, where Tesla has completely reinvented how electricity and torque interact. That's the story of the Model 3 motor, and it's about to get even more exciting. When Tesla launched the Model 3, most people thought it was just an affordable electric car. But hidden under the hood was a quiet revolution, a motor that would redefine what electric vehicles could do. This wasn't the old AC induction motor from the Roadster. Tesla introduced a permanent magnet synchronous reluctance motor, a mouthful of a name that hides an incredibly smart design. It combined the best of both worlds, instant torque, high efficiency, and intelligent adaptability. The magic of this motor lies in software-driven control. It constantly monitors speed, road conditions, and battery load, adjusting its output in real time. In the city, it provides maximum torque for quick responses. On the highway, it switches to efficiency mode, stretching the battery further without sacrificing performance. But Tesla didn't stop at software. The motor's hardware is just as revolutionary. Neodymium magnets are placed with extreme precision inside the rotor, held securely so they don't scatter even at high RPMs.
The result?
A motor that's more powerful, more stable, and remarkably durable. This breakthrough also made the motor lighter. Less weight means better efficiency, longer range, and less strain on the cooling system. And because it has no brushes or other wear-prone parts, maintenance is minimal, a silent testament to Tesla's engineering mastery. In short, the Model 3 motor isn't just a mechanical upgrade. It's an intelligent powerhouse that quietly does more than anyone expected. It sets a new standard for EV motors, proving that innovation isn't always about flashy launches or dramatic announcements. Sometimes it's about quietly perfecting the heart of the machine. And while Tesla was perfecting this motor, the industry watched in awe and fear. Because if one car company could achieve this level of efficiency and intelligence, the race to dominate the EV world would never be the same again. At the heart of nearly every electric motor lies a tiny but mighty element, neodymium. These rare earth magnets are astonishingly strong, allowing motors to deliver immense torque from a surprisingly compact design. Tesla and other EV makers relied on them for years, squeezing more power into smaller, lighter motors. But here's the hidden danger. Neodymium is rare, expensive, and geographically concentrated. Over 80% of the world's supply comes from China, giving one country immense control over material that powers the future of transportation. Any disruption, whether political, environmental, or economic, could ripple across the global EV market. Mining neodymium also comes with a heavy environmental price. Extracting it requires toxic chemicals, massive water usage, and generates waste that contaminates rivers and soil. Entire communities can suffer, all to supply the magnets that make your car move. Tesla realized that this dependence was a ticking time bomb. If the goal was mass-market EVs and millions of cars running autonomously, relying on a single rare material was risky, both financially and morally. That's why Tesla started exploring alternatives. By rethinking motor design and using smarter software, they could achieve similar performance while reducing or even eliminating reliance on rare earth magnets. Neodymium still delivers incredible power, but Tesla's shift shows a new truth. Real innovation isn't just about strength, it's about sustainability, scalability, and resilience. The next step in Tesla's journey wasn't bigger magnets. It was a smarter, cleaner solution that could be produced anywhere in the world.
That solution?
Ceramic magnets. Tesla's answer to the rare earth problem came in the form of something surprisingly simple: ceramic or ferrite magnets. At first glance, they seem ordinary, the kind of magnets you might find on a fridge or in a household appliance. But Tesla saw something others didn't. With the right design and software, even a weaker magnet could outperform expectations. Ceramic magnets have three major advantages. First, they are abundant and inexpensive, meaning production can scale globally without geopolitical risk. Second, they are environmentally friendly. Mining ferrite doesn't poison rivers or devastate land like neodymium extraction. Third, they are durable and stable, lasting the life of the motor with minimal maintenance. The challenge was obvious: these magnets aren't as powerful. Alone, they would make a slow, inefficient motor. But Tesla approached the problem like a puzzle. By carefully designing motor architecture and pairing it with advanced algorithms, the company allowed the motor to extract maximum efficiency from every magnetic pulse.
The result?
A motor that runs intelligently, adapting torque and energy usage in real time, while being cheap, sustainable, and scalable. It's a perfect example of Tesla's philosophy. Innovation isn't always creating something entirely new, sometimes it's about using old ideas in smarter ways. With ceramic magnets, Tesla isn't just thinking about today's cars. They're preparing for millions of future vehicles, autonomous fleets, and a world where EVs can be made safely, affordably, and responsibly. And while this might seem like a small technical detail, it signals a larger shift. The EV industry is moving from raw power to smart design, from scarcity to sustainability, and from expensive materials to universally available solutions. Next, we'll see how Tesla's motors have evolved from mechanical components into something much more remarkable: software-driven brains that control the car itself. Tesla's motors are no longer just mechanical machines, they're smart, adaptive, and alive. Thanks to advanced software, every motor is constantly monitoring conditions and making split-second adjustments to optimize performance, efficiency, and battery life. When you drive through city traffic, the motor senses the need for instant torque, giving the car a smooth, responsive push without wasting energy. On the highway, it automatically shifts into efficiency mode, reducing torque just enough to stretch battery range while keeping acceleration seamless. This isn't guesswork. Algorithms constantly analyze data from sensors inside the motor, battery, and vehicle systems. Current flow, magnetic fields, rotor position. Everything is tracked and adjusted in real time. The motor literally thinks for itself. And the result is astonishing. Tesla vehicles don't just move, they learn to move smarter, delivering peak performance with minimal waste. Energy that would normally be lost as heat is preserved, torque is applied where it's needed most, and battery life is extended. The motor has effectively become the brain behind the car, integrating with regenerative braking, vehicle dynamics, and even autonomous driving features. It's a silent, invisible network that ensures every journey is smoother, faster, and more efficient than before. This is where Tesla separates itself from nearly every competitor. Others still rely on static designs and brute force power, while Tesla combines hardware, software, and intelligence into a single cohesive system. The implications go far beyond a single car. When every motor is software-driven, the potential for fleet-wide optimization emerges, where millions of vehicles can adapt to traffic, energy demand, and even weather conditions in real time. And that brings us to Tesla's ultimate vision: autonomous fleets powered by motors that are not just machines, but thinking partners in motion. Tesla isn't just building cars anymore, it's building a networked fleet of intelligent vehicles that could transform transportation forever. Each car isn't a standalone machine, it's a node in a growing, connected system capable of learning, adapting, and sharing information in real time. The motor innovations we've explored, software-driven controls, regenerative braking, rare earth-free designs, aren't just about performance. They're about scalability. If Tesla wants millions of self-driving cars on the road, every motor must be efficient, reliable, and globally producible. That's where ceramic magnets and intelligent motor algorithms come in. They make mass production feasible, sustainable, and cost-effective. Imagine fleets of Teslas communicating silently, optimizing routes, conserving energy, and even balancing the grid by sharing power when needed. Autonomous driving isn't just about convenience, it's about efficiency at a planetary scale. This vision explains why Tesla invests in every layer of its ecosystem: batteries, charging stations, AI software, and of course motors. Each innovation isn't isolated, it's part of a holistic system designed to support a future where electric, autonomous vehicles dominate the roads. And the stakes are enormous. Successfully deploying such fleets would not only cement Tesla's lead in the automotive industry but could reshape urban life, energy consumption, and transportation economics worldwide. Yet even with this vision, Tesla faces a challenge: creating millions of smart, durable, and efficient motors without compromising quality or sustainability. Every step toward this goal is a delicate balance of engineering, innovation, and strategy, the very things that have made Tesla a revolutionary force. But as the world watches, one thing is clear: Tesla's future isn't just about cars. It's about quietly rewriting the rules of mobility. Not every revolution comes with headlines, fireworks, or dramatic announcements. Sometimes the most powerful changes happen quietly, unnoticed by most, yet reshaping the world in profound ways. Tesla is a perfect example. From Nikola Tesla's AC motor in the 1800s to Elon Musk's modern electric cars, the story of innovation has always been about seeing potential where others see ordinary. Musk didn't just copy old ideas, he studied, reimagined, and improved them for today's world. AC motors became brushless, software-driven, and magnetically optimized. Motors became intelligent, adaptive, and sustainable. And in every step, Tesla pushed the boundaries silently, letting performance and impact speak louder than marketing. The quietest revolutions often have the biggest ripple effects. A car that moves silently, regenerates energy, adapts to conditions, and uses sustainable materials may not make headlines every day. But millions of such cars on the road slowly change habits, expectations, and industries. Tesla's innovation teaches a subtle but powerful lesson: true change doesn't always roar. It rotates, silently and steadily, reshaping everything it touches. So the next time you see a Tesla on the street, remember, it's not just a car. It's a testament to human ingenuity, persistence, and vision. It shows that even old ideas, when revisited with intelligence and care, can become the foundation for the future. And that's the real innovation, the kind that doesn't just impress the world for a moment but quietly moves it forward, one rotation at a time. Tesla's journey isn't just about cars, batteries, or motors. It's about reimagining the way the world moves. From the humble AC motor of Nikola Tesla to Elon Musk's intelligent, sustainable motors today, one thing remains clear: innovation is rarely loud, but its impact can be monumental. Every element of Tesla's design, from regenerative braking to software-driven motors, from rare earth solutions to ceramic magnet alternatives, reflects a philosophy that goes beyond speed, range, or luxury. It's about efficiency, intelligence, and sustainability. Every innovation is a step toward a future where electric vehicles aren't just a choice for the wealthy, but a solution for the planet and millions of people worldwide. The quiet evolution of Tesla's motors shows us that real progress isn't always flashy. It's the cumulative effect of smart ideas, relentless testing, and bold thinking. When the world watches, it sees a sleek, silent car. But under the hood is a revolution in motion, a carefully crafted system that powers performance, safety, and sustainability simultaneously. Tesla's story also reminds us that innovation is not about perfection at the start, it's about learning, iterating, and improving. The Roadster's AC motor was a beginning. The Model 3's permanent magnet synchronous reluctance motor is a leap forward. And the next generation, with smarter design and sustainable materials, promises to push boundaries even further. Ultimately, Tesla is doing more than leading the EV market. It's reshaping industries, redefining expectations, and inspiring a generation to think differently about technology, energy, and the environment. The quiet revolutions, the ones that work behind the scenes, refining, learning, and improving, often leave the deepest mark. So the next time you think about electric cars, think beyond speed, think beyond luxury. Think about intelligence, sustainability, and vision. Think about the quiet rotations under the hood that are silently moving the world forward. And as Tesla continues to innovate, one thing is certain: the future of motion is here, and it's quiet, powerful, and unstoppable. If you enjoyed this deep dive, don't forget to subscribe, because the world of technology moves fast, and the next breakthrough might be closer than you think.